going to write a balanced equation for the reaction of hydrogen and oxygen, both of which are diatomic. H2 plus O2, what do you think we're going to get when we have hydrogen and oxygen? H2O, you got it. Okay, not balanced yet. Let's do it. We need a 2 in front of water to balance the oxygens, and then a 2 in front of hydrogen to balance the hydrogens. So we're going to start by having 4 molecules of hydrogen gas and 4 molecules of oxygen gas that react to form water. Okay. I'm going to make a little key over here. I'm going to use gray for hydrogen, and I'm going to use red for oxygen. Doesn't matter what you use yourself, but make sure that you make a little key. These are diatomic, so we're going to start with 4 molecules of each. 1, 2, 3, 4, and then 4 hydrogens. 1, 2, 3, 4. Okay. The difference now is we're not going step by step by step, one reaction at a time, but we're going to just think about the very beginning and the very end. For me, I think circling one set of reactants that will make a reaction at a time and drawing your products is particularly helpful, so that's what I'm going to demonstrate here. We know every 2 hydrogens and 1 oxygen are going to give us 2 waters, so I'm going to circle 2 hydrogens and 1 oxygen, and I know that's going to give me 2 waters, so I'm going to go ahead and draw that in my product or my after box. We know by now very well what water looks like, so let's go ahead and make sure and make it bent. That's 1 reaction's worth. Okay, I have another 2 hydrogen and 1 oxygen I can use to make another 2 waters. 1, 2, 1, 2. Can I make any more? No. So now I can't make any more waters, but I still need to make sure that my picture is going to follow conservation of mass. So I need to use that to show that I have 2 oxygen molecules that are still left over. So now based on this, we can answer our questions. Okay, how many water molecules can be produced? Well, we wind up with a total of 4 molecules. Okay. And our excess reactant is the oxygen. And this reason is so simple. It's excess because there's 2 left over. There's 2 O2 molecules left, which I also just answered the next question. 2 molecules, O2. So we can do a BCA table for this to help us out based on the particle level. Now I'm going to focus in on the BCA table. As you're going along, you're going to have your particle picture you can look at as well. 2H2 plus O2 yields 2H2O. I'm going to add in product, subtract reactants. And so we also know we're going to start with 0 moles of product. Remember, BCA tables, we're going to use moles. Okay. So instead of thinking about these as molecules, let's think about these as moles. Actually, no, let's go ahead and think about it as molecules. We can do these as particles as well. It's not going to be realistic to count molecules or particles, which is why we focus on moles. Okay, we started with 4 molecules of each of these reactants, and we used up all of the hydrogen, right? We used up all of the hydrogen, and we had 2 oxygen molecules left over. So that's going to tell us what our change needs to be. Okay. We used up 4 molecules of hydrogen. We used up 2 molecules of oxygen. And then we made 4 molecules of water. Remember, when your coefficients in your balanced equation are the same, the change in moles is going to be the same. So it doesn't matter if we're doing this in a particle picture or a BCA table, we're still going to find out that we can make 4 molecules of water. We're going to have oxygen in excess because it's left over 2 molecules left over. Okay. Then our final thing here is based on the 2 methods of analysis before, what determines how much product can be made from a particular reactant mix. We've also talked about this already. It doesn't matter whether we're looking at the particle picture here or whether we're looking at the BCA table. The big key here is the reactant that's used up completely determines how much product can be made. So, that's why it's called a limiting reactant. Okay. Go ahead and go on to do number 2, which is another particle level question, before we start looking at math with grams.